Hey, I'm Mike from BizFlow AI. I've been benchmarking local LLMs on my AMD R9 700 for the past 6 months. 32 gigabytes of VRAM, ROCm 7.2, and more failed model loads than I can count. Everyone talks about tokens per second, no one talks about whether the model can actually finish the task. Today, that's changing. This is the first real-world benchmark for local LLMs running actual automation tasks through Hermes Agent. 4 tasks. 2 models. 1 winner. Let's go. Here's the problem. Most benchmarks you see online, they're measuring prompt eval and token generation speed. That's fine if you're writing poetry. But when you're building real automations, disk monitors that alert you before your NVMe fills up, model backup scripts that know when your SSD is too full, GitHub repo analyzers that handle rate limits and pagination, analytics dashboards that handle rate limits and pagination, analytics dashboards that pull data from your actual websites. Speed means nothing if the model generates code that crashes on first run. I wanted to know, which local model actually produces working Python scripts for everyday tasks? Not theoretical, not synthetic. A quick hardware check. AMD Radeon PROW7900, also known as the R9 7000. 32 gigabytes VRAM, Dell Precision 5820 Xeon W233 125 gigabytes system RAM, ROCm 7.2 Ubuntu with a custom kernel. Everything you're about to see runs on this machine. No cloud inference, no API calls. Local weights, local execution, real results. Task 1. NVMe disk monitor with Telegram alerts. The model gets a prompt to write a Python script that monitors NVMe usage every 30 minutes. Logs with timestamps, and sends a Telegram alert when usage exceeds 85%. Both models, Laguna XS 2.1 and Grug-27B, generated working scripts on first attempt. Laguna's version used pathlib, type hints, and structured logging. Grug's was simpler, procedural, used util disk usage. Both correct, both executable, both passed. Task 2. Automated model backup script. The model writes a script that finds all gguf files in mama.cpp/models, calculates total size, checks available space on an external SSD at /mnt/crucial, and performs a dry run showing what would be copied. Laguna's output included recursive os.walk, proper JSON summary with file count and total size, and pre-flight safety checks. Grubs used glob with hard-coded paths and standard Python logging. Both detected the SSD was 90% full and aborted safely. Both correct. Task 3. GitHub Repo Analyzer. The model writes a script that fetches repository data via the GitHub REST API, handles 404, 403, and rate limit errors with retry after parsing, saves a JSON summary with stars, forks, and open issues. No credentials required, just standard HTTP requests. Laguna produced a full OOP class with exponential backoff and jitter, fallback mechanisms, and proper error hierarchy. Grug's was procedural with if-else error handling and standard retry logic. Both fetched Facebook/React successfully. Both handled errors correctly. Both passed. Task 4. StoryReserve Analytics Dashboard. The model writes a script that reads local storage tracking data from the StoryReserve website, generates a markdown report with page view statistics, unique visitors, and session durations, then saves it to the analytics directory. Laguna's version used pathlib, proper markdown formatting, and summary statistics. Grug's was simpler but produced the same correct output. Both generated readable reports. So what were the results? Both models scored 40 out of 40. Every task generated executable code that ran successfully on first attempt. But here's where it gets interesting. Laguna XS 2.1 finished the full benchmark in about 119 seconds. Grug-27B took about 173 seconds. That's roughly 32% faster for Laguna. But the bigger difference was code quality. Laguna consistently produced production-ready Python, type hints, docstrings, pathlib instead of string paths, OOP classes with exponential backoff, pre-flight safety checks. Grug's code was simpler, more readable, more My verdict? If you're building a personal AI agent team that runs real tasks on your local machine, Laguna XS 2.1 is the better foundation. Not because it's faster, though 32% matters at scale, but because it writes code you'd actually want to maintain. Grug-27B is excellent for experimentation, lighter on VRAM at 14 GB versus Laguna's 28, and produces perfectly functional scripts. Both are legitimate choices. But for the BizFlow AI stack running Hermes Agent automations 24/7, I'm keeping Laguna as my default. How? So that's the benchmark. Real models, real tasks, real results. If you found this useful, hit subscribe. We're building the go-to channel for Laguna, llama.cpp, and AMD R9700 lived experience. Drop a comment if you want to see Grug-27B A3B MOE tested next. That's the 20 billion parameter mixture of experts variant, or Quen 3.627B, which just dropped. All scripts and benchmark data are in the description.